Hello students, this is part 2, okay, about chapter 5 client-centric consistency model. This is the third client-centric consistency models, which is called monotonic rates, okay? So let's try to discuss about monotonic rates. Monotonic rates ensures that rates from the same client are applied in same order across all replicas, okay? This prevents the issue where different replicas may apply the same client's rights in conflicting or out of order manner. A data store is tied to be monotonic right consistency if the following conditions holds or some of the criteria should be fulfilled. The first one is write operation by a process on a data item X is completed before any successive write operation on X by the same process. Okay, that is not just talking about different process, rather same process you have to take care here. That is why write operation on a copy of data item X is performed only if that copy has been brought up to date by means of any preceding write operations which may have taken place on the other copies of X. Let's try to observe from those images A and B. Okay, here they have their own orders. Okay, about monetary rights, which is one of the third client-centered consistency model. So A is correct and B is not correct. So let's how A is correct and B is not correct. Here, a data store that is monotonic right consistency is A. There is a process P that performs a write operation on X value as local copy of I or Li. There is a write of X1. Later, P performs a write operation on X at L2 of write of X2. Okay, so here a write of X2 requires that write of X1 is updated on L2 or local copy of before it. That means uh, X1 should be propagated to uh, X1 on L1 should be propagated to L2. Okay, so why this is correct. Uh, let's see B. A data store that is not monotonic right consistency. Why? What is the reason here? In B, the reason is there is a right of X1 has not been propagated to a local copy of 2 or L2, which was only it is at local copy of 1 or L1. So it is not monotonic right. The other one is, or the fourth one is read your rights. Okay, the read your rights consistency model guarantees that after a client writes a value to a data item, any subsequent reads by the same client will reflect that right, ensuring that the client always sees its own updates immediately. A data store is said to be read your rights consistency if the following conditions holds or criteria should be fulfilled. The first one, the effect of a write operation by a process on a data item X will be always be seen by a successive read operation on X by the same process. Okay, so that is why a write operation is always completed before a successive read operation by the same process, no matter where that read operation takes place. Let's observe the image A and B here also. Okay, A is correct and B is not correct. So let's elaborate why A is correct and B is not correct. The same thing from the view of X1 is not propagated to L2 or local copy of 2, why it is not corrected in B side, but from A it's already propagated so that it is corrected. So a data store that is read your write consistency, there is a process B that performs a write operation on X at L1, that is local copy 1. So write of X1, later P performs a read operation on X at L2, that's already propagated. Okay, so if it is propagated, set right, the set right of X1 semicolon X2 states that right of x1 is a part of set right of x2, so it is already propagated. Okay, so it is correct. So figure B or image B is wrong, or it's not correct. A data store that is not reach your right consistency here is the right of x1 is left out of the set right of x2. That is not propagated. That means that is not the effect of the previous right operation, while the process B have not been propagated to the local copy of 2. Why it is not correct. Okay. And the other client-centered consistency model here is writes follow reads. Okay. Writes follow reads is a consistency model that guarantees that once a client reads a value, any subsequent writes to the same data item by that client will follow the value that was read. This model ensures that the client's updates are logically connected to their previous reads, preventing situations when a write made overrides data that the client has not seen. So a data store is said to be right for its consistency if the following conditions or criteria should be fulfilled or held. What's that criteria? A criteria is a write operation by a process on a data item X following a previous read operation on X by same process is guaranteed to take place on the same or a more recent value of X that was read. Okay, so that is why any successive write operation by a process on a data item X most recently read by that process. Okay, here. So let's try to observe those images A and B. Here also A is correct and B is not correct. Let's elaborate why A is correct and B is not correct. A data item, a data store that is writes follow reads is consistent. There's a process B that performs a read operation on X at a large local copy of then read R of X1. Okay, so the right operation that leads to read of X1 also appear in the right set of L2 or local copy where P later performs on right of X2. Okay, here in B, a data store that is not right follow reads consistency. The right operation that leads to R1 did not appear in the right of set at L2 before P later performs a right of X. That means it doesn't propagate. Okay. Example right follow reads consistency can be used to guarantee that users of a network news group see posting of a reaction to an article only after they have seen the original article. So let's try to summarize client-centric consistency model. Okay, here we have to focus the 5 client-centric consistency models: eventual consistency, monotonic read, monotonic writes, redo writes, and writes follow reads. Keep in your mind those the 5 important client-centric consistency models. Okay, now let's try to summarize the chapter which is called client-centric consistency model. The core idea is consistency from a single client perspective because it guarantees for how an individual client experiences data across different replicas. Okay, so that we have to keep in your mind, as I told you or mentioned earlier, eventual consistency, monotonic reads, monotonic writes, redo writes, writes follow reads. Okay, and the other important key insight or key point in this chapter is used when strong synchronization or strong consistency. Okay, well, strong consistency is it has high synchronization. So if it has high synchronization, it's costly. That ensures personal consistency of for each user across different locations and servers. Okay, this is all about chapter 5. Chapter 2, module 2, chapter 2, which is called client-centric consistency models. Okay, so that if you have any question, Any misunderstanding? Any help?